Hi guys, so today we will be discussing about the derivative of the fractional part of x. Okay, so what is fractional part of x? So firstly I would like to explain it quickly. So for example, you have any integer, for example 2.3. Okay, so if we split 2.3 in two parts, so that is 2 plus 0.3. Okay, now this 2 is, what is this 2? 2 is the integer part, okay, and 0.3 is the fractional part. Okay, so suppose I am taking 5.5. Okay, so 5 would be the integer part plus 0.5. This is the fractional part. So if we suppose, let us assume x equal to 5.5. Okay, then what would be this fractional part? It would be 0.5. I hope this concept of fractional part of x is clear. Okay, and what is this 5? We can also say that this 5 is something greatest integer function. 0.5 and greatest integer function x is equal to 5. And guys, if you want to understand this greatest integer function, okay, of x in details, so I have already uploaded one video related to this greatest integer function. You can go through my previous video and you will understand this concept. Okay, so now I hope this fractional part of x is clear. So right now I would be telling you how to find the derivative of this fractional part of x, which is in the question. Okay, so let us start. So as right now just I have explained you that x can be splitted into the greatest integer function plus fractional part. Okay, for example, I have already given you the example. For example, x is 5.7, then this would be 5 and this would be 0.7. Okay, now if I want to find the derivative of this, then how can I find it? So from this equation, I can write here x. If I take this x in this side and this is in this side, then I can write in this way, x equal to x minus x, right? Now, if I take the derivative in both sides, so we would be having d over dx equal to dx over dx minus d over dx. Okay guys, so what's the derivative of x with respect to x? We know it would be 1, right? If I say what is the derivative of greatest integer function, so please go through my previous video. I have already found out the derivative of this greatest integer function. So the greatest integer function derivative is always 0 until and unless x should not be integer. Okay, integer. If x would be integer, we cannot find. This is undefined. This is not differentiable. This concept in detail you can find out in my previous video. You can go through it. And if so, the derivative of greater integer function is always be there when x is not the integer. So now, if x is not the integer, then we have this 0 value. 1 minus 0 equal to 1. So I would say, since this derivative will be coming out when x is not the integer, so this derivative will also be only applicable when x is not equal to integer. Otherwise, what would happen? If x would be integer, this would be undefined, and if this would be undefined, so this would be undefined. If this is non-differentiable, so this minus non-differentiable equal to non-differentiable. So we can say the derivative of d or fractional part of x upon dx is always 1, okay, when x is not equal to integer. Okay, I hope this concept is clear. Okay, so now I will prove this with the help of a graph. So let's make the graph of this, okay? So as I already told you, that's x equal to x plus x. So this value would be always be between, what can I write here? Between 0 or 1. It can be equal to 0. When it would be equal to 0? When the value of x is integer. Okay. Suppose x is equal to 5. Okay. Then in this case we can write like x equal to x plus x. Okay. Now this greatest integer of 5 plus 0. So in this case, the value of fractional part of x would be 0. So fractional part of x can be 0. Okay. Can be 0, but it cannot be 1. It would always be less than 1. So it will always be less than 1, but greater than or equal to 0. Okay. I hope this is clear. So if I make a graph of this function, so let's make this one as this. Okay, so the fractional part of it is going through like 0 and 0, 0 and this. 1 cannot be. It cannot be 1, right? Again from here, this. Again from here, this. Again from here, this. Why this? This is a sign like at x equal to 1, the value of fractional part of x would be, so when x equal to 1, suppose x is equal to 1, okay, 1 equal to plus fractional part of x equal to 1 plus 0. So when x equal to 1, this is the x-axis, when x equal to 1, so greatest integer function is 1 and fractional part is 0. So fractional part would be 0. That's why I have made this as an open dot. Open dot is saying here like at x equal to 1, y equal to 0. Okay. So I hope this is clear. So where y, if you see here, this is the x-axis and this is the y-axis, and y equal to, this is the graph of this. So now I am just trying to find out the value of this, right? So if you see here, this is a function, right? It is varying from 0 to 1, okay? So in my previous video, I have already told the value of the derivative is always a tangent at any point A. So at any point, if you see, like from here, what is the tangent on this line? So tangent, it is itself a tangent, okay? So the slope of this tangent would be the value of this. So what's the slope of this tangent? So if you see it in a depth manner, so it is something, the value of function y equal to x. So if x is less than or equal to greater than or equal to 0 and less than 1, so we can always say y equal to x, right? So you can understand what I am saying. If y equal to fractional part of x, so if x is between 0 and 1, okay, then y equal to x, because it is itself a fractional part. So dy over dx would be 1. Hence proved. I have already proved you the value of this is always 1, right? And with the graphically, if you see the tangent of here, and you can see here at integer value 1, 2, 3, 4, you can say it's not differentiable because there is no particular tangent. There are a lot of tangents, right? But here, at any point, there would be only single tangent, which is it itself. It is a tangent, right? So this is a concept. So I hope everyone is clear. If you are not clear, you can comment, okay? And I will explain you in detail if you haven't understood anything, okay? So we can write as a conclusion. We can write here. We can write here that the value of derivative of fractional part of dy over dx is always equal to 1, okay, where x should not be integer. I hope this is clear to all. If you have any doubt or any question, you can ask me in the comment section. Thank you guys.